Please subscribe and you can download this code from description below. In Python, the decimal module provides a decimal class for working with decimal floating point numbers. The decimal class is designed to offer more precision and control over floating point arithmetic compared to the built-in float type. In this tutorial, we'll explore how a decimal object is encoded in Python, and we'll provide code examples to illustrate its usage. The decimal class in Python is part of the decimal module, and it represents decimal floating point numbers with arbitrary precision. The precision is determined by the number of significant digits stored for each number. Unlike the float type, which uses binary floating point arithmetic and has limited precision, the decimal class allows for precise representation of decimal numbers. You can create a decimal object by passing a numeric value, integer, float, or string, to the decimal constructor. Here's an example. In this example, decimal underscore number 1 is created with an integer value, decimal underscore number 2 with a string representing a floating point number, and decimal underscore number 3 with a floating point number. Internally, the decimal class encodes its numeric value using a tuple of 3 components, a sign, positive or negative, a tuple of digits representing the integer part of the number, and an integer exponent representing the power of 10 by which the other components are multiplied. Here's a breakdown of the encoding. Let's explore the internal encoding of a decimal object using the as_tuple method. In this example, we create a decimal object with the value 123.456 and then use the as_tuple method to retrieve its internal encoding. The components of the encoding, sign, digits, exponent, are then printed. Understanding the internal encoding of decimal objects can be useful when working with precision-sensitive applications or when you need to analyze and manipulate the underlying representation of decimal numbers. ChatGPT